Okay, so the same exact idea. Now I'm going to shade here the inside and the outside functions. The outside function, notice that the entire thing is being raised to the 5th power. So this is what we're going to call the outside function. And then the inside function is this w to the 4th minus 2w. Okay, so if I find the derivative of this guy, since it's the function, a function of a function, remember first you get the derivative of the outside, which is the red one, so we're going to use the power rule. So we bring the 5 over, so we get 5, and then we leave the inside alone, so 5w to the 4th minus 2w. Subtract 1 from the exponent, we get 4. Okay, then we move in, and now we're going to get the derivative of the inside. So the derivative of the inside is going to be, well, inside we have to use the power rule again. So the derivative of w to the 4th, that's 4w, subtract 1, we get 3, minus the derivative of 2w is just 2. And there we've applied the chain rule. Okay. Let's do one that's a little bit less obvious. Let's say we have g of x equals 2 to the negative x. Okay, now here in this one it's not as obvious which one's the outside and which one's the inside function, but well, this is a exponential function. And so notice that the negative x is inside of the exponential function. So the outside function is the 2 being raised to the power, and in this case the inside is negative x. Okay, now let's go back and remember just real quick to make sure that we know how to get the derivative of this one. If we get the derivative of simply 2 to the x, remember this, the derivative of the exponential functions is just itself times the natural log of the base, which in this case is 2. So we have this extra factor. Okay, now in this one though, we have inside, instead of having x, we have negative x, so we have to treat that a little bit differently. So we have to use the chain rule. Okay, so we apply the same rule. We have the derivative of the outside function, leaving the inside alone, so make sure you're careful with that. So the derivative of 2 to whatever power is itself, leaving the inside alone, times natural log of 2, which is the base. Now that's the derivative of that, but then we have to go inside and get the derivative of the inside, which is negative x, so the derivative of negative x is negative 1. And you would do this if this negative x would have been anything else as well. And we'll do some harder examples with this type of a function in a little bit. Okay, now in this problem, it's starting to get a little bit trickier. Notice that we're multiplying two functions, and we also have here a function of another function. And so because they're multiplying, we're going to have to use the product rule. And inside of the product rule, when we get the derivative of this one, we're going to have to use the chain rule. So it's a double whammy. Okay, so let's get going here. So the very first part is that we have to use the product rule. And so this is going to be the first function, and then I'll do the second function black. Okay, so remember the product rule says that you get the derivative of the first times the second, so this is derivative of the first, which is just 1, times the second, leaving it alone. So this is e to the negative t squared, plus, now the first one you leave it alone, and then you get the derivative of the second. Okay, but now when we get the derivative of the second, now we have to use the chain rule. So let me color this guy red. Okay, so the chain rule says get the derivative of this guy. Okay, well remember the derivative of the exponential is just itself. So the derivative of the exponential is itself, leaving the inside alone. So e to the minus t squared. Remember in the chain rule, when you get the derivative of the outside, the inside is always left alone. That's really important. Okay, and then you get the derivative of the inside. Well, the derivative of the inside is minus 2t by using the power rule. And that's it. We're pretty much done. We could, if we wanted to, simplify it a little bit more. Notice that you have an e to the negative t squared common in both, so I can factor this out. E to the minus t squared, and inside I would be left with 1 plus, if I combine this t and this negative 2t, this would actually be minus, minus 2t squared. And that I get by multiplying the two t's. And so this is just slightly more simplified.